All right. So I had an idea what I was going to be talking about. And of course, like many things, I investigated further. And upon investigating further, I realized I didn't really know what was going on. So I need your help, the folks in the audience and the folks that may be watching at home temporally in the future as well, to try to figure out what's going on. And the reason why I say that, and one of the reasons, or probably one of the primary reasons I'm here at the monastery, is I noticed a lot of really smart folks out there. And a lot of them, they kind of seem to be talking about the same thing. And I'm like, I think some of these people should know what's going on. And actually, by doing some minor innovative trolling, I would claim, between Professor Keating and Professor Wolf, and that was how I actually came across you, because I then got trolled by Nolan a little bit. And all of a sudden, I'm like, oh, look, theoretical physicist, Thad Roberts. I'm like, all right, well, let me follow this guy. I like that type of stuff. So, trolling aside, I had an idea, and in about a month, I have to give a small presentation on a poster discussing what I've colloquially called eternal cyclic cosmology. Shout out to Professor Penrose. And it's basically utilizing the same concept, except rather than how do we get to this next aeon, basically there would be a flow, some form of cyclic nature. And at least according to the model that I have in my head that's still in flux, it looks like we're in a realm that persists under balance. So let's start off with what we have, and we'll get to the second part about where do we live, because I had an idea, and now I'm unsure. So initially, to some of the previous videos, basically let's say we have I'm going to put in quotes, universe. Spell. Whatever that may mean. And Thad had just given a great talk the other day that really helped, and also kind of seemed to confirm in my mind that I really didn't know what was going on, because as I'm trying to conceptualize things, I just try to reduce it down to just the simplest way it could happen, based upon what we know within the standard model, and based upon the best estimates that we have for our measurements for the constants in nature at this time. So that's a terrible hypersphere. It's basically a sphere. I realize it's 2 dimensions. And you're looking at it on a 2-dimensional screen, most likely. But if we're assuming this is a sphere, the current thought is somewhere at the center, we're going to have basically a figure 8 knot. And this is going to be current estimates down at the magnitude of about 10 to the negative 8 meters. Incredibly small, incredibly larger for different particles and everything. But as far as what we could actually conceive, maybe a mote of dust or something like that. Really not something you're going to notice if you're cruising through space, going any multiple, actually just cruising through space at all. And we're thinking we have a radius of approximately 10 to the radius is actually about 10 to the 34 meters. How the heck do I get that number? Okay, not negative 34. Well, 1 over the Planck length. It's an assumption. When you do that, you get some surprising things and not so surprising things. So you end up having a diameter. It's roughly about, well, let's do it over here. So total diameter, we're talking about 10. I think it's like 1.237. I'll attach the notebook with the calculations. 35 meters. Okay. And to the best of my knowledge, okay, if we're out here, what do we have? We have galaxies. Okay, we got stars. We've got stars, galaxies. They're swirling around. There also seems to be this dark energy, this cosmological constant, if you would, that seems to be creating what many intuit as expansion. Perhaps that's the case. Totally open to that. Perhaps my simple brain just thinks of it more as, well, if this is kind of like the most beautiful snow globe in the world, but you had some form of a pump or a hyperpump in the center. Because when we do our calculation, we look back like, all right, there was some very hot, dense state, and it appeared to be high entropy, but then it kind of smoothed out, and people argue back and forth. So what I'm thinking, just in the current state as we know it, and based upon at least what's in my head of our models, okay, so what happens if you had a source? You know that from electromagnetism. Well, if you have a source, you must have a sink. What if that sink is right around the same area? Because in my mind, as we see, I can toss in one of the cool animations that Echelon put together. If you have this highly articulate motion, if this thing is whirling around, that's like Planck frequency there, it might be ingesting and extruding. What would it ingest? I don't know. What do we have? We've got galaxies, and the galaxies are flowing away, and we got supermassive black holes, whatever those things are, and they're gaining mass, and they're getting bigger. And apparently yesterday we found something within, I think it was our own galaxy, but it was eating about a solar mass a day. Well, that was a couple billion years ago, so probably pretty ginormous right now because it was pushing the Eddington limit. So again, I believe we're going to probably keep on finding much larger and larger black holes, supermassive, ultra, hypermassive, whatever you want to call them. But at some point, this flow would go in here, and you're going to basically have an inversion of a black hole, whatever that means. I don't know. Is that going to create space-time, or space-time itself expanding out? Is it going to create a quark-gluon plasma that we may observe as what we believe to be a Big Bang? Possibly. Now, the problem I run into with this is this made a lot of sense to me. I'm like, all right, you've got matter, space-time, whatever it is, coming out. And according to, Professor Sharma's paper, and I believe Jonathan, I forget your last name, but it was something that Dr. Unziker actually brought to our attention, in that it's an old model where basically if you did happen to have a rotating universe, there was rotation, and we were kind of spinning around in whatever direction. Well, that seems to be able to account for inertia. And I still need to go through the full paper. I meant to do it the other day. Question, Casey?
Well, so the one thing I have, the one obvious question is, so, like obviously, then it has to have a tremendous amount of fluid dynamics because the outside it'll be a limit to how much anything could move because once you start expanding the outside of the pizza, you get, like even literally a pizza. If you spun the pizza at like a record
volume must be maintained.
RPM, once the pizza gets like to a certain size, the outside of the pizza will be going light speed or nearly light speed, and it won't even be that big of a pizza. It'll be a pizza like of a number probably with a radius we could at least discuss in some sort of real terms. So there would be then a tremendous amount of turbulence problems, like everything that gives rise to the Navier-Stokes equations or all those types of problems. And every other types of, there's just a whole lot of geometric problems that will happen with the whole thing rotating like that.
That's if the whole thing is rotating so that it's radial, so that the rotation is greater as you go out.
Yeah.
You've got an inverse rotation, so that the rotation of the out is 0, and the rotation maximizes as you go towards the center, right?
So that's.
I mean, that's one of the reasons why I'm doing this, because this isn't even. To be fair, I would go on.
So no, so that's exactly, there's a proposed solution too.
Yeah.
If you're showing it's an out.
In fact, that problem becomes a crutch for your model because, a positive crutch, because it means there's a limit. If you're having things rotate, there's a limit, the speed of light.
Yeah.
That's fast as they go. So if you're carving boundaries with that speed of light and creating divisions at that speed, you want that to be on the inside.
Largely, that's my point, is that there's some
that
rules.
Forces you to have
there's
a
some
distortion that's quantized, not infinite. Right?
Exactly. There's some rules that very, very greatly bound that, because we can think about actual pizza that starts to challenge the issues. Like it literally is made out of a crust with some sort of astronomical cheese and whatever, but it's.
I love that because my problem comes in with the crust. That's ultimately where I'm going. I threw that in a little bit. I don't think I had said it on video before, but I just wanted to give a shout out because the other thing that would do is, just make this a little bit labeled better. All right. But what that also does is in Jonathan Fay's paper, I believe, he basically takes that idea and says, well, what you could also do, the thing that would help to solidify that model is you would have a mass at the center. Like, that seems to be what we're saying right here. And there's a lot of other ways we could go, but the big problem that I'm having is when you actually toss the calculations into Wolfram Alpha, you get, where are we? Yeah, you had a bit of a interpretation problem because I'm looking at this, and again, the assumption is we have four-dimensional hypersphere. Now, we're working in a model that has 5 dimensions. And I remember in 44, Thad was saying at some point, you have those 5 dimensions of parameterization, and as those circles are closing, and this is more of a thing of cosmogenesis, so I would say it's perhaps more speculation, but 2 of those axes will be consumed, and under this inversion motion, whatever it might be, and again, could be totally wrong. That's why I want a broad spectrum of folks to have access to this and have their thoughts, because, no, go on.
Well, yeah, the torus thing, which we were talking about the other day, makes the thing very obvious, because if you're inside, and no matter how you go out, because it's recursive and because it inverts your position, no matter how far your calculation takes you out, even if you can go out as far as you can possibly imagine, that just actually brings you on a loop, a hyperbolic loop, back into something with, so every distance you're going is actually double the distance that you're going, because it implies that there's a to and from in all distance transits, actually, in a grander scale, like a torus, because you're not only going to somewhere, but you're also going from somewhere. Or that's not exactly clear phrasing, but
it's kind of like the game of asteroids, where it's like you go off the string and you kind of just loop back around. Yeah.
So like the bound that you think of, like what's past that is like not a logical construct within that.
It's not the way my mind normally works. Yeah.
If you're inside the donut, like you can keep going out. It just brings you back into the other side of the donut.
Yes.
And so then what happens inside the inner ring of the torus is the real question. You know, how is that bound dealt with?
That's a good question.
That's easy enough to see. It's just like pure light, pure light energy. And the reason why C is because it sources off of the inner ring or something like that, and that's a bound itself, because once you're at it, you can't accelerate past it. You're just there. So, and that's also, time is irrelevant to light. That explains why time is irrelevant to light. Because it's anchored to this other place that's on the inner ring in the grand construction.
So when like you just pointed out, when we take 1 over a hypersphere, when we invert that hypersphere, we've learned from John that we get a torus. I'm like, that's pretty neat. So this is 139. Okay, so when I do the calculations, I throw it into Wolfram Alpha, and I'm leaving off the initial magnitude. I'm just throwing in the powers of 10 for brevity's sake. But you get an radius, 10 to the 34 meters. Content, I should probably actually label the dimensions because this is very important. All right, so that's meters to the 4th for the content, because it says content, not necessarily volume. And then hyper surface area. This is the one that's got my mind boggled. 110 to the 105 meters cubed. So when I look at that, I'm like, okay, aside from my horrific penmanship, when we do this calculation, throw a radius The inverse of the Planck length, we claim 10 to the 34 meters gives us content. 10 to the 39 meters to the fourth. All right.
10 to the 139?
Yes, 10 to the 139. My question is, and I have a potential idea for a solution about this with your guys' help, the hypersurface area, because the area of a four-dimensional hypersphere is in 3 dimensions. I'm like, well, we live in a realm that appears to be 3 dimensions, and we always separate it as 3 plus 1. 3 dimensions of space, 1 dimension of time. Now, my question is, where do we live? Do we live in the 4-dimensional, which I could easily say, okay, I can intuit that. It's like time is in there because, well, time is in here. Or is it something along the lines of we live in the surface, a 3-dimensional surface, and time is a flow?
Yeah, obviously. That's why physics are good to know. And for example, like when something falls, it's not actually falling. It's the forces that are acting on it, et cetera, et cetera. But don't try that off a building if you're a biological human without a parachute.
Probably not a good idea.
Because all of your theory about actually the Earth is rising up or I'm going down or whatever it is will just end up in you dying or being paralyzed. So, the 3D experience, So I say there's strong evidence for the 3D experience, and strong evidence for the 4-dimensional construction.
Yeah, there's a bulk that's 4-dimensional, so the content inside is 4-dimensionally bound. Mm-hmm. But that binding itself, the logic that controls it, is 3-dimensional.
Okay. So no, because that was, to be fair, that would actually probably make it a lot easier, just because, okay, a lot of folks have put out there, we have ADS-CFT, basically the generalized claim, and I apologize, Professor Baldacin, if I'm getting this wrong, but basically we have some boundaries, the surface, the information itself is within the surface, and if you have all that information on the surface, you could tell what's going on within the bulk. Jonathan Gorod explained that to me.
And so its most concrete sort of mathematical formulation is in terms of what's called the ADS-CFT correspondence, the idea that ADS, which is that is to say anti-de Sitter space, which is a kind of a geometrical gravity theory that can exist on the interior of a surface, that can be encoded in terms of what's called a CFT, a conformal field theory defined on the boundary of that surface. So you can have in the 1 plus 1 dimensional case, which is the case where ADS-CFT has kind of been studied most rigorously, you could imagine something that looks a bit like a soup can. So you've got like a sort of you've got a cylinder, and so you've got a bulk gravity theory on the interior of the soup can, and you've got a sort of quantum field theory on the boundary of the soup can. And somehow, just by knowing the quantum field theory on the boundary, you can determine everything about the gravity theory on the interior. And so it's in cases like this where, as you correctly allude to, the sort of the notion of whether the universe is really 3-dimensional or really 2-dimensional becomes a little bit subtle, because you could say, well, the sort of gravitational part of the universe, the bulk part, is 3-dimensional, but the sort of the quantum field theoretic bit that encodes that bulk theory could itself be 2-dimensional. Everything going on in the 3-dimensional universe could be encoded on a 2-dimensional surface at the cosmic horizon.
If we have a proper label on the can, will we be able to tell the soup on the inside?
Yes, right, exactly. That's precisely the point, right? That everything there is to know about the soup, you can infer just by knowing the label on the exterior. Yeah, that's the idea.
To me, as basically like a soup can, if you have the proper label on the can, you can tell everything that's going on with the soup inside. That was expressed generally, and usually I think he was doing 1 plus 1 or 2 dimensions there. Now it gets a little more wacky and a bit hard to intuit when you get to 4 dimensions, sir.
Just so if another real easy one is, so Bart Simpson, right?
Yeah.
Bart Simpson lives on the screen.
Yes.
The servers that generate that stuff for Fox or whatever, and then put it in the airwaves. He's in the airwaves, all that, but he's not in the airwaves. Those are digital ones and zeros that are manipulated in a pattern, like a tiling that will then represent, or it's a pattern that once it's tiled will represent him. but it's not executed. And so it's not the same thing. Like, for example, you can cut up parts of Bart Simpson and turn his face sideways and put his bottom half of his face on the top half of his face, and you could still say that's Bart Simpson. You can cut him up into a lot of pieces, actually, and still probably look at 64 cut of Bart Simpson and still know it's Bart Simpson. But if you cut up any of the ones and zeros, you won't have Bart Simpson anymore in the code. You may completely destroy the code by even removing one value. It's probably not, because there's a lot of redundancy built. But fundamentally, therefore, if Bart Simpson lives, he lives in the screen only. Like, the rest of the stuff is the machine that builds him.
Bart Simpson to observers like us is on the screen, though the underlying information for Bart's system is actually coded in some way there.
Yes, exactly.
Okay?
That's what I mean by that.
Yep.
The whole system, the TV doesn't run unless it runs on the logic of the servers that feed through into the broadcast airways and all that. But ultimately, those are just ones and zeros until you see Bart Simpson.
You got to get the RF frequency to go in to the displays for the observers like
all
us.
those are the translations, but when it's Bart Simpson, that's where we live. Like, Bart Simpson lives in the television screen. That's like a logical argument for it, you know? About what is existence? What are characteristics? You know, I'd argue that having the ability to be constructed is not the same thing as having an identity.
Now, full disclosure as well, I could put in the numbers for a 5-dimensional hypersphere. I could embed the 4-dimensional sphere in 5-dimensional space. I'm going with this because I think we might have some clues. To be fair, irregardless, yes, a Boston term, of whether you do a 4-dimensional or 5-dimensional, you embed it, it still gives you 10 spherical homotopy groups. That's kind of cool. The reason why I'm going with the 4-dimensional hypersphere in 4-dimensional space is it does assume a center of C1, C2, C3, C4. What does that mean? Okay, my intuitive that is just because the figure 8 knot does happen to have a unique 0, 0, 0, 0 point. Mathematically, maybe you call it a singularity, but it's not necessarily a singularity in and of itself. It's that everything goes around that 0-dimensional point. It's wrapping in the smoothest possible way with a minimal balanced manifold, is the claim. So now, if it's just the bulk, I can groove with that. The only reason why I thought potentially we may have something here is because Dad was giving a talk, and the way that we're generally coming at it, we have our hypercone over here. That's a terrible looking hypercone, but all right. We have our hyperbolas over there, and we need our sheeted hyperbolas. Going over here, yes. A lot of the more basic geometry here, but if we believe we live in the simplest possible universe, when we want to keep things as simple as possible. Because if there's one thing I've learned from Professor Wolfram, it's that you can have very simple elementary rules, and when you continue to iterate them, you can get fantastic complexity to the point where things ultimately seem to become computationally irreducible. Basically, to try to figure out what's going on, well, that's pretty hard. So we need to intuit the best we can, and ultimately, it's kind of cool because it means the game must be played. You got to live your life to figure out what's going to happen. I don't know about you guys, but it's like, all right, I have an idea in my head. It's going to go exactly anytime I try to force something like that, it never happens. It usually goes terrible. But when you live your life, you try to do the best you can. I feel that that's something that resonates. Or at least Professor Dawkins coined the concept, I think it was chapter 4 or something, of the selfish gene. Meme. It's like a gene. It's something that can replicate and go through. So therefore, everybody literally affects everybody. I know, sorry. Philosophy aside, I say that as I'm philosophizing, but that's okay. But I'm looking at this, I'm like, okay, and we need our torus, basically our space. Imagine it's a terribly drawn torus. All right. But basically, we'd have a ring around here. Go back there, go back there. Okay. We're saying this is temperature. I'm just looking at this. I'm like, okay, I can start to intuit this. I'm like, that space dimension can get really, really big. Okay, maybe we live in that and we're bounded by temperature. And that would actually make a lot of sense because temperature seems to have a relation to
Time.
and entropy.
Yeah.
And entropy. So basically, direct information. And if the general form is, if we can tell the information on the boundary, we should be able to determine what's in the bulk if we have some form of stereographic projection.
There seems that there's like, if you think about it, it's of different lengths, but any given thing, information has, in some ways, a very short half-life because, so there's the parent of the information, right? Which is the original piece of information.
Mm-hmm.
It's just like a game of telephone. There's only a guarantee, and then there's not actually a guarantee, but if there is a copy, the only copy is the first copy. All copies after that are so that is like, for example, the node. And then after that, these are all modules that go out past it, right? And so there are copies of copies. There's problems that can happen from them that are not the same as a copy off of the original.
It's well, you're promulgating things. I believe there's also like the no cloning theorem and stuff. I'm not really.
This is in reality, not in like set theory or something. In set, if it was a perfect copy, then it would be a perfect copy, and there's some things. But in real dynamical systems, like you can see it, like a cell that copies itself, and when a cell divides, only that first dividing cell retains the true original characteristics. As the thing goes on, they start to gain new characteristics. So when the thing divides, it eventually doesn't divide exactly even, and you get new traits. That's part of the way.
You're going to have different differentiation, even though you may have very simple underlying substrates there. See the.
I'm not a biologist, so.
Oh no, me neither.
Feel free to flame me in any comments.
No worries.
Also, if anybody who's listening has a favorite whiteboard compass, they may want to suggest it in the comments for making circles. Somebody's like, oh, I got the best thing for making circles on the whiteboard.
I should probably just grab a piece of string. That would work too. But
yeah, I looked at
that's a good call.
They don't seem like they're.
All right. So the issue that I run into. The issue I run into is also you want to follow the evidence where it leads. And when you stumble upon something, try to be skeptical. We had gone over this before, but we also come across something that just by doing some calculations, because, okay, this is a little side note. It's the side note of how we got here is when you take the derangements for our inversion boundary that we're using for all those things, and you have, just take the number of derangements, Planck length times, Planck mass times Planck length over Planck charge squared. Because the claim is, for each of those dimensional boundaries, you have a number of different...
35?
Yeah. I will slowly become better. Okay. One mistake at a time. So, 8 derangements for mass, 35 derangements for space, 18 derangements for charge. What does that give us? It gives us 78. Wow. Oh, my information sync is off. 70 over 81.
Yes, because you were going to write an 8.
Yep, exactly. Yep. And so I'm like, 70 over 81. That means absolutely nothing to me. And I went on Wolfram Alpha.
Before you move on, though, why were you asking for the 35 over 18 squared again?
Oh, because this is our inversion boundary. So basically, this would be equal
Those
to...
are the degrees of freedom in our inversion
Yes,
boundary.
this would be the number of derange. It's the number of derangements for our inversion boundary. So basically, I stripped off the rest of the numbers, and if we're saying These are derangements. This is an important thing. Maybe we would find something interesting. I found something interesting. Comes out to be 35 over 6. This is the TVE. That's 20 TVE. All right. This is 6, 20 vertex entropy constants. 20 squared. That kind of blew my mind. Now again, I don't know it is actually truly something because one, it hit it perfectly. So I'm a little skeptical on that, but what I did by following the evidence, I'm like, okay, what could this mean? Because this was a constant that popped on a Wolfram alpha that was actually defined by MathWorld, I think like 2003, so about 20 years ago. It was only named there, it had been a thing, but it didn't have a name. So once it was given a name, I could search for it. And what this is this assumes that basically you would always have 3 vertices that would go in and 3 vertices that would go out. So basically, if this was going in, and this was going in, and that was going in, this would be going out, this would be going out, this would be going out. Okay. Kind of seems like a lattice structure there. I'm like, okay. So 35, that's the same number that pops out for something to do with space. And then 6 times 20 vertices. I literally just searched polyhedra with 120 vertices. I just did 6 by 20. Why not? So I did that, and I found a couple of things. One of them, Rick had been talking about a little bit before, the dodecahedron, basically that 120-sided, the fairest of dice. And then the thing that really caught my attention was the, let's go down here, the 120 cell. Because it has some very interesting properties. We did a quick presentation, but just to recap, link to Wikipedia and everything and any other relevant articles. Basically, it is a convex. Basically, when you take like a pentagon, if you try to tile it on 2 dimensions, it doesn't quite fit. But if you curl it up into the 3rd dimension, you get a dodecahedron. That's really cool. And I think I'll insert the clip from Professor Bayes. He gave I think the Dinkin talk about 11 years or so ago.
Here's another example of how the number 5 is sort of awkward. You could say, well, okay, I didn't succeed in tiling the plane with pentagons, but when I tried, at least it folded up to form this nice shape, the dodecahedron. So maybe I can fill up 3-dimensional space with these guys. I can take a bunch of these guys and pack 3-dimensional space with them. But if you try to do that, that doesn't work either. You get these annoying little cracks here. So like it comes darn close to perfectly fitting, but it doesn't quite work. And so that's another example about how like nothing quite matches when you're dealing with a number 5. But you could say, well, okay, tough. I'll just keep on going ahead. It didn't quite work, but I'll just stick on another layer of these dodecahedra anyway, as if I was still. So I'm putting on a new layer of these guys onto the ones that I already had and matching them up perfectly on these pentagon faces. Of course, now the cracks are getting worse. So you may wonder why I'm doing this. Well, I'm building up the suspense. That's what I'm doing. And so then I stick on another layer. Well, it's getting even more worse. There's getting to be lots of room. And another layer. Well, it's getting even worse. And then I'll put on one more dodecahedron, not a whole nother layer, just one more. So you notice that's just this, well, it's hard to tell, but that's just the same as that with just one more. And now if you count them, obviously there are exactly 120 of them. And then you can say, okay, what's so great about that? Well, here's what's so great about that. So I said that with the dodecahedron, if you tried to tile the plane with pentagons, it didn't work so well, but if you curl it up into the 3rd dimension, then it fits together into this beautiful shape. So now here, similarly, this thing is a mess. It didn't really work. But if you curl it up into the 4th dimension, then you get some great thing. You get what's called the 120 cell. It's a four-dimensional shape that has 120 dodecahedra.
And what he said is, if you take a dodecahedron and then you place another layer dodecahedron, doesn't quite fit. Place another layer dodecahedron, and it starts to get worse. You put another layer dodecahedron on, and so forth, until you get to the point where it's just kind of crawling all out and everything. It looks weird. And you put one final, so you get to 120 dodecahedron, and it looks like some crazy tentacle monster. Okay, that's in 3 dimensions. If you were to curl up in the 4th dimension, you get this. So put a cool picture up here. And the 120 cell is actually a 4-dimensional platonic solid.
That's 600 vertices.
Yeah, well, it goes to the 600 cell.
Well, no, it's 600 vertices on it.
Right.
So I would think that, like, there are some constructions that have 120 vertex, actually, and anything that has 60 vertex in 3 dimensions, when it's translated in 4 dimensions, gains, well, not, I don't know if that is true of any.
It doesn't have 120 vertices. You're absolutely right.
A regular polyhedra in 3 dimensions, when it's translated in 4 dimension, gains an extra reflection symmetry. So it doubles the symmetries from rotation to reflections. That's true of like icosahedron and dodecahedron, which go from symmetry group of 60 to symmetry group of 120.
This is next, and the reason, no, that's good to point out, because again, my scientific method was I type it in Google and look for interesting things.
Yeah, so there might be a better, that's a cool looking picture, but there might actually be a better geometric model.
The 600 cell, 120 vertices.
All right.
See, that was one of the reasons why I'm showing this, because it has interesting properties, but that's also important because somebody had conjectured the other day that there must be 2. So perhaps there's a domain, maybe a codomain. I mean, that seems to be something that's built within logic there. Yeah, the 120 cell, and they both have pi for all these different permutations and everything. We can go over that. But basically, you end up going from this crazy thing in 3 dimensions. It curls up into that very shiny thing. It has all its rotations and everything. But the thing that really stuck out to me about the 120 cell, for some brevity, was how it kind of intertwined. And just, it was this picture right here. Basically, when you start looking at it like this, I'm like,
that looks 3-dimensional lattice. It forms quite nicely.
I would also suggest if you look at the great 120 cell, also.
Oh no, all these different. There are many different versions. There's so much to explore. Like this page to go through literally is probably about an hour plus worth of research.
Actually, there's only 2 of them.
Okay. What we got?
That's it. That and this.
Okay.
They're the only such polytopes that are self-dual. So there isn't lots of them. That's just these 2.
Okay. We're narrowing our search space.
I mean, just for that particular property, there isn't, as far as I'm aware, that this Schlafly Hess polytopes. So there's only 10 of them as regular ones, and there's only 2 of them that are self-dual.
Oh, there's 10, and 2 of them are dual.
So,
That's pretty cool. Again, and also when you're working in a model where basically you have 5 base dimensions, you're talking about double covering them, and then all of a sudden you start looking at the atomic mass unit, and you're like, is base 10 built into reality? I don't know. Maybe just a happy coincidence for observers like us. But I'll put the thing up on the screen, and when I just look at that, and I'm like, it seems to be kind of familiar. Now, again, what I was initially thinking, now I'm not going to draw that out because I have nowhere near the talent, but basically I'm kind of seeing some stuff come down, kind of looks like a hyperboloid. We have our top over here, okay, our sides. Yes, I'm not really drawing the sides well, but these things come down and they seem to meet. It almost kind of looks like an hourglass. And I'm like, well, at least for this, based upon my understanding, if it's composed of, and again, this is more rampant speculation, just an interesting thing to kind of get out there. If you have to have one, let's just say, maybe it would appear on the outside as kind of spherical. I don't know, maybe it's a knot. And just to spitball what I was thinking about why we could potentially be in the information domain is because the outside of this, within the inside, there's only 119. On the outside is basically the final one, which basically acts as the skin of the boundary there. That's the 120th one. So I was just thinking, I'm like, well, what if we were to live in there in a three-dimensional space that has to be under constant flow, and time is literally just a flow. Again, rampant conjecture there. It was just interesting coming across these things, just, what might have 120 vertices? What are some of the first things that come up? What might we be able to try to intuit? And again,
I think you have great. I think this is a great, like geometrically, this is a very great avenue of investigation from my perspective.
Me too.
I appreciate
you're
your
gonna have
work
a logic
here.
and you get it and it's balanced and it needs to tile things.
Yeah, I appreciate your work here, and I appreciate this. This is good right here. I think this is pretty good work. I mean, you're not making any claims, but this is one way things can unfold, and this is a little bit of a proposal for a roadmap. So
yeah, to me, I'm seeing right away, if you compare this picture or the one on the computer to the other hyperbolic structure you're putting, first of all, they look similar, but what's the difference? One is quantized, the other one's smooth, right?
And if we're leaning towards there's some discreteness, then we would
You're going to have to get the logic of the discrete tiling. And so this is a pretty interesting option. Also, the number 120.
Yeah.
Does that have anything to do with the 5 dimensions that we think the universe is composed of?
Well, 120 is 5 factorial.
Yeah, that's okay. So with 5 things factorized into 120 things, and then we tile them.
These are some of the reasons why I found it interesting, because basically we're really going right now is derangements is before, right?
Yeah.
All right. So derangement of 5, exclamation before equals 44. And if we do 5, the exclamation point after, we get 120. I don't know if I'd call that an inversion, because we didn't put 1 over that, but it seems to be. Casey, would this fall under like a reflection? Would this be like a subgroup or?
Well, first off, I just want to correct and probably think I made the wrong statement about the 120 cell. Does that version of it have, how many vertex does that version have?
This one does have 600.
Okay.
Yeah, this one does have 600. It's dual, the 120. Yeah, the dual has, yeah.
I just want to make sure.
Oh, yeah, no, it's the 120 cell. It's weird because they call it the 120 cell, but it has 600 vertices.
No, I was wanting to make sure I was talking.
But the cells, the number of cells is different from the number of vertices.
Right. So, go on.
No, I just wanted to make sure that I stated that.
So the problem I have with that is I'm like, all right, so if we were to try to make the claim that we live in some 4-dimensional platonic solid, I mean, that would sound really cool, but I'm like, all right, but that seems would almost be like a reverse. Rather than living in the bulk, we live in the information there. So what the heck would be going on with the bulk? So I don't know. Maybe it's one of those things we need to explore the geometry further. I'm open to ideas.
I think that there's a number of.
This one?
So if you just think about morphisms, there's nothing to really write here, but just if you think about morphisms and everything being a morphism, so time itself is the guarantee of morphism, if something changes. But anything that you're talking about is either like an abstraction, like a meter is like an abstraction, it's an idea of a unit, Like it may be a real thing too, but it's just an abstraction. Like there is space, and then we have to make a fixed unit, right? But like measuring a meter is an action, and something happens because of it. Everything that really happens, no matter what, changes the things around it. Through space and time, things happen. So if you're looking at morphisms here, and then you're looking at this group, you're looking at has a number of closed morphisms to other grand structures, but there's a limited amount of them. They have unique properties in each configuration. There are not any others that exist except for this group, right? So they have relation to the torus and to the hypersphere and to the triangle and to the hexagon, and so there's
the 4-dimensional versions too.
Yeah, so this is a special group. that has what do you call homotopy to everything.
Homotopy.
Like when you like even greater than that, like the conceptual version of it, where when you take something, you translate it into a different construction. So there's a limited set of constructions, just like there's a limited set of elements in space, time, length, or space, time, temperature, charge, and mass. So it's a similarly confined and constrained geometric set here that goes between 3 and 4-dimensional geometry, and the rest of those geometries are conceptual, but aren't necessarily. You could like argue for them as just conceptual operation spaces, as opposed to like geometric dimension, and so there's ways to represent these things by
the different stuff that they do.
Because
we have a limited number of things that now we're working with.
I mean, you can take obviously the sort of concept to the dual, how that works. You can subgroup the things, and then you can make basically like more normal polygons we're familiar with. Like you can convert it into the basketball that you.
The ones we're usually familiar with are the 3-dimensional platonic solids, right?
Mm-hmm.
Yeah.
But in 4 dimensions, how many platonic solids are there?
You can do all the platonic solids, I believe.
But there's 6 in 4 dimensions, and there's 5 in 3.
Does it continue to go up? It would continue to go up like that, or does it restrict?
Oh, I actually don't know how many is any above that. I just
Okay.
3 and 4.
No,
Okay.
I mean, in a lot of senses, there's like sweet spots with geometry, and even in higher dimensions, like I'll just say that like I don't believe there's a lot of people who actually have the bandwidth inside their head to really know like a picture about a 94-dimensional situation. It's like you could say things, but who could there's not a large group of people who would read the work in the first place. And if everybody who did read it, there's just not even that many people who could respond to it with like a good set of counter facts.
You could write down a whole bunch of words. You can do the calculations. I can say words. I did this with that. I'm like, I was kind of parroting some words. I could say words. Did I really intuit what? No. It took me a long time and a bunch of work and sitting down with that and trying to go over these things to try to get a little bit of a grasp of what's going on. And I think I'll claim I'm getting a little bit better.
Well, we can't actually really conceive of 4 dimensions, but it's pretty clear that.
I think we can.
Yeah, well, it's pretty clear that.
Okay, I'm not saying we are. I'm saying I think there's no inherent limitation for consciousness to penetrate 4-dimensional logic. We practiced in 3, and those of us who have been educated have practiced in 3, and maybe people have practiced in less than 3 in some cases, right? But that 3 isn't even what we're naturally get. We're getting just 2-dimensional images, and we're making up a model in our head that puts it together in 3 dimensions. So we're conceiving the 3 by putting it together in our head. We can do the same thing for 4 if we had a model that worked, right? We'd be able to penetrate those actions and those connections if we could logically put them together in a way that was useful.
So
that's the goal.
If that is the case, then I would guess that there must be things that already do that, because we specialized in something, everything specialized in something. So if that's a thing, something already specialized in it, just like we specialized in pattern recognition and ambulatory things and locomotion, and so that's why we do what we do. But like lichens specialized in something totally different, and they have amazing talents to manipulate novel DNA structures that we can't do anything like that. Even our best science can't touch or even understand what lichen does. So, I would argue that if we can perceive the 4th dimension, that some thing probably has already evolved on Earth that does already perceive it. Whether we can understand that it does.
Maybe, but we also have progressed a lot as a species over time to perceive things differently and be aware of new features like electrons and so on, or electricity.
We've adapted.
Like cockroaches could still sense those things far greater than us. For example.
So Casey, now again, I'm not sure it's 4 dimensions, but at least Professor Henry Segerman, if you just search anything with his name and hyperbolic on it, he actually gives, the model that we have was actually generated initially by him and his associates, I think Saul Schleimer and et al. And as they put that together, they made the code available. So that's one of the reasons why we're trying to make things available, because it's like, do we have the answers? No, we're working on it. We have a puzzle, and we're slowly putting together the pieces of the puzzle. So is it going to be me that has the answer? No. Is it that? Maybe you, maybe somebody watching at home right now just has come across something that they thought was really interesting, but they don't know how to approach something. If you have something that's interesting and you want to help humanity move forward, like people always are saying and everything, then feel free to reach out. Reach out, you can do a behind the scenes message on the Physics Monastery website. Send me an email as well. We'll toss all that stuff in the doobly-doo below. And basically, I love that term. Shout out to the Green Brothers. But what Professor Segment has, when the hyperbolic space-time and a couple other cool videos where he's going through a library and keeps on coming out the same things, kind of like you were describing earlier there. What he does is, as you're going through, you're seeing all these things going like 90-degree angles and everything like that, and all of a sudden things aren't as you intuit. So I figure, I'm like, okay, that's probably why we adapted as we would, because if we saw reality like that, my mind would probably just explode. So we have the ability to reduce our incoming information, to filter, if you would, to adapt to our environment here on Earth. So, but Casey, you had given me another idea a few minutes ago. The 120 cell is dual to the 600 cell. Perhaps, speculation, that has something to do with this being squared. Because I just looked at that as, oh, just 6 times 20. Let's see what comes up. It's actually squared. So very often when we're doing our dimensional analysis, if we have, might have length over time, or we might have length over time squared, because that would be acceleration there. Because now we have we're using 2 units of time there to achieve that acceleration. So I'm like, well, we're looking for 2 of these things. I also put them in a square box for extra emphasis. So, yeah, dad jokes from non-dads. But yeah, that's really what I was spitballing. Questions,
I
commentary.
have a question, but I'll
Sure.
leave it off the video, so I'll leave it for later.
Okay. Question.
I do want to actually make one comment, which is not to say that I do like and appreciate your idea about the idea that we're not coded to see in 4D, and so that's that's at least a primary problem to any idea of seeing in 4D. And so I definitely am not trying to be against that idea. And my statement about that something else would have probably evolved isn't like an attempt to negate what you're saying, but is to say that there is, if that's true, there's also probably something out there.
I think we're still evolving to it. So
Well, perhaps the statement is there is something that is yet to evolve as we know
What I'm
it.
trying to say is that there's probably a jellyfish that sees in 4 dimensions anyway, that's in somewhere we don't know
I
about.
can't say there's not.
Yeah, I don't. With the places on our own home we haven't explored.
Look what we've evolved to do. Look what Lichen have evolved to do. So
Plus, we see on a scale, a meter-ish scale. When we conceive the world when we look around, we're not actually paying attention to the microscopic things. We don't even see that.
How much do we know
Some
about
things that are
distances?
sensitive to the microscopic things might have different cues in order to
Exactly.
make sense of the
And the
world.
blue bottle butterfly, 15 primary colors, right there, for example. The mantis shrimp has whatever it is, the 30 something.
It's got like the best eyes in the world.
Different interface with the world. So you
Yeah.
might be making sense of the world more rapidly or just different sense than others. Yeah.
And things like lichen that live for hundreds or thousands of years in pseudo-colonial structures with novel biological structures that they got from DNA that they stole from other creatures. So what kind of time scales they're concerned with or what their survival ideals are would be hard to even have any idea, because they're not doing what bacteria or fungus is doing, even though they live in a lot of the same places. They stole those DNA structures and repurposed them to do different things with them. But what stole them in the first place, and what's the thing that is repurposing these other, like Cladonia DNA structures and other ones that are known? So You know, like
What is going on?
The idea is that there's a lot of very interesting biological structures, even here computationally, that we don't have any idea about.
All those are more clues for us too.
Well, that's the thing. It's like I don't know. My personal opinion here is I think we're in a very unique position where we are within our solar system, that I think we have all the ingredients and tools that we need to actually just get to a better level of what's going on, perhaps increase our consciousness and be able to do something cool. I don't know, explore the cosmos.
And the more we prioritize it, the more we're actually going to make progress there.
And I just want to tidy up my information comment from earlier, which was to basically note when you were back in that talk about the concept of information flowing out and all that. My point was starting with the idea of like
you actually helped me start to crystallize a new idea that actually makes more sense. So thank you.
It was like a founder of the information, which is the original information event, and then like it can be tiled and copied by like observers, for example. But then that information lives, but it begins to have its own life also, or it dies. Or it just ends. But there is...
It blows up or shrinks, goes away. So it can't be tiled.
It transforms.
There's a so there's a chain, though, if you think about it. And then, so if that, again, was the building, there's a neighborhood, those like streets that it goes to. But eventually the roads end. And so whatever that building was, like you can think of that as the shadow that it casts over its neighborhood by how long the information chains went. You know, and when did they die? A really tiny little shack just like doesn't even cast a shadow on its neighborhood, but a grand structure is going to throw, on top of the mountain, is going to throw shadows all around for a long, you know.
There's a cool optical thing. I forget where it is in Scotland, but as you're driving, the house it gets smaller.
And so that's
and stuff like that because of your vantage points.
So
there's a lot of cool stuff.
That's related to event horizon as a concept, though. You know, because there's a point.
Because there's a limit to the neighborhood effects.
Yeah, like there's a point where it's like, well, this can't really go back anymore, or this doesn't.
Casey, you know what that's
you can't retrieve the original content anymore at some point.
You know what that's related to? This actually has a relationship to that because this has a built-in relationship, at least according to before, for a photon to either get trapped or exit. So I think I was just putting this out here for clues just to wrap up. So basically, we're doing a little bit of spitballing here, and if this is something that you guys are interested, you'd like to maybe come to the Physics Monastery at some point, maybe share your ideas, or just even reach out, try to figure out what's going on. Any support is greatly welcome as well. Running on a bit of a shoestring budget right now, but I think we're getting our name out there. Folks are seeing the work and everything, and we want to have folks that have great ideas, that want to make a difference, that want to act in good faith. Hey, reach out. We'll see what happens. Maybe it works. Maybe it doesn't. But other than that, thank you.
Cool. Good job.
Thank you.